In mathematics, we are familiar with many pairs of inverse operation: addition and subtraction, multiplication and division, raising to powers and extracting roots, taking logarithms and finding anti-logarithms, and so on. In this module, we discuss the inverse operation of differentiation, which we call anti-differentiation or integration. Hello everyone, I am Dr. Geraldina Fernandez, Assistant Professor, Department of Science, the Bhopal School of Social Sciences. So far, we concentrated only on that part of calculus which is based on operation of derivative, namely differential calculus. The second major operation of calculus is integral calculus. The name integral calculus originated in the process of summation, and the word integrate literally means find the sum of. The brief outline of today's session is, we'll start with the definition of integration, the use of constant of integration, the symbol of integration, indefinite integrals, general property of integrals, some standard integrals, and at the end, we'll solve some questions. Now, we'll start with the very first topic, that is integration. So, integration is a way of adding parts to find the whole. The mathematical process which represents the inverse of differentiation is known as integration or anti-differentiation. So, the next concept is the constant of integration. To understand the concept of antiderivative more clearly, consider the following example. Suppose we differentiate the function y is equal to x square. We obtain dy by dx is equal to 2x. We take one more function, that is x square plus 1, and we differentiate it with respect to x. The result is again 2x. Similarly, we will take the third example, the third function x square minus 10, and we differentiate it with respect to x. This time also we are getting the result as 2x. All these functions have the same derivative 2x, because when we differentiate the constant term, we obtain 0. Consequently, when we reverse the process, we have no idea what the original constant term might have been. Hence, from this point of view, an antiderivative of the given function f of x will always be incomplete up to a constant. Therefore, to get a complete antiderivative of a function, an arbitrary constant, which may be denoted by either c or by k or by any other symbol, must be added to the result. The arbitrary constant represents the undetermined constant term of the function, which is called as the constant of integration. Next is the symbol for integration. The symbol chosen for expressing the operation of integration is given by this, which is the old-fashioned elongated S, and is selected as being the first letter of the word sum, which is another aspect of integration. Thus, if an integral of f of x is fx, we write it as integral f of x dx, that is equal to f of x plus c, where this symbol is the integral sign, f of x is called as the integrand, dx is the variable of integration, capital Fx is the indefinite integral, and c is the constant of integration. All this idea is behind what we call indefinite integrals. Now let f of x be a function, then the family of all antiderivatives is called as the indefinite integral of f of x. Now here we are taking two functions, small f of x and capital F of x, such that the derivative of capital F of x is small f of x. Then this capital F of x is called as the antiderivative of f of x with respect to x. In mathematical notation, it is expressed as if the derivative of capital F of x with respect to x is small f of x, then the integral of small f of x dx is f of x plus c. This f of x is the indefinite integral of small f of x and c is the constant of integration. Next, we will study the general properties of indefinite integrals. So, the first property of indefinite integral is that the integral of the product of constant and a function is equal to the product of the constant and integral of the function. Here k is the constant. Next, the second property of indefinite integral is that the integral of sum or difference, here it can be sum or difference of two functions, is equal to the sum or difference of the integral of two functions. That is, integral of f of x plus g of x dx is equal to integral of f of x dx plus integral of g of x dx. Moving on to some standard integrals. So, the first formula is integral x raised to the power n dx, and that is equal to x raised to the power n plus 1 divided by n plus 1 plus c. Here the condition is n should not be equal to minus 1. This formula is also called as power rule. Now, the second formula for indefinite integral is integration e raised to the power ax dx is equal to e raised to the power ax divided by a plus c. C here is the constant of integration. Next, the third formula for indefinite integral is of 1 by x, integration of 1 by x, and that is equal to log x plus c. The fourth formula is integration of 1 with respect to x, and that is equal to x plus c. So, this is our fifth formula. The fifth formula is integration of cos x dx, and that is equal to sin x plus c. The sixth formula is integration of sin x, and that is equal to minus cos x plus c. Now, the seventh formula is integration of sec square x dx, and that is equal to tan x plus c. Eighth is integration of cosec square x dx, and that is equal to minus cot x plus c. Now, the ninth formula is integral sec x tan x dx, and that is equal to sec x plus c. The last formula is integral of cos x and cot x dx, that is equal to minus cosec x plus c. Now, we will solve few questions related to indefinite integrals. So, here the first question is evaluate integral 2 e raised to the power x minus 4x square dx. You have to find the value of this integral. So, we will start with, we will write the integral minus 2 e raised to the power x minus 4x square dx. Now, here since we have two terms, therefore, this integral will be distributed with all the two terms. That is, we can write it as 2 e raised to the power x dx minus integral 4x square dx. Now, as we know that the integral of the product of constant and the function is equal to twice of integral e raised to the power x dx by the general property of indefinite integral. Similarly, for the second term also we will apply the same property, that the integral of constant and function is equal to the product of the constant and integral of the function. So, now here we have the formula for integration e raised to the power x dx, and that is equal to e raised to the power x. Similarly, we have power rule for integration, that is x raised to the power n dx is equal to x raised to the power n plus 1 divided by n plus 1. So, the last term was e raised to the power x and x square. So, on integrating we will get 2 e raised to the power x minus 4 x cube by 3 plus we'll add the constant of integration at the end. So this is the value of the integral. Now the second question is, you have to find the value of the integral 2x square minus 3x raised to the power 4 dx. That means we have to find the value of this integral. So we'll start the solution. Integral 2x square minus 3x raised to the power 4 dx. Here we have two terms in this integral. So this integral will get distributed with both the terms. So here this is equal to integration of 2x square dx minus integration of 3x raised to the power 4 dx. Now we'll use the general property of indefinite integral, that is the integral of product of constant and function is equal to the product of constant and integral of the function. Similarly, we will do this with the second term also. Now here we will use the formula of power rule, that is integration x raised to the power n dx is equal to x raised to the power n plus 1 divided by n plus 1. For the very first term, n is 2, and for the second term the value of n is 4. So we will use the same formula for integrating. So here we will get 2x square was the function, so that will become x raised to the power 2 plus 1 divided by x raised to the power 2 plus 1. Then we had minus 3x raised to the power 4 dx. So minus 3x raised to the power 4 plus 1 divided by 4 plus 1. Plus we will have to add the constant of integration. So the final value will be 2x cube divided by 3 minus 3x raised to the power 5 divided by 5 plus the constant of integration. So this is the value of the integral. So the third question in this series is that you have to evaluate the integral to x raised to the power 3 by 2 plus 1 by square root of x dx. So we have to find the value of this integral. So we will start with the integral is 2x raised to the power 3 by 2 dx plus square root 1 by square root of x dx. So this can be written as integral twice of x raised to the power 3 by 2 dx plus the integral will get distributed with both the terms plus integral of 1 by square root dx. So we have the formula, and the formula is for integration x raised to the power n dx, that is equal to x raised to the power n plus 1 divided by n plus 1. Here we can add the constant of integration at the end when we get the solution. So here the power of n is 3 by 2, and there the power of n is minus 1 by 2. Since the square root is in the denominator, so when you shift it in the numerator, the power of n will be minus 1 by 2, and here the power of n is 3 by 2. So we will use the same formula for integration. So here it is 2x raised to the power 3 by 2 plus 1 divided by 3 by 2 plus 1 plus the value of n is minus 1 by 2. So according to the formula, we will get minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1, and that is equal to, and plus constant of integration. So that is equal to twice of, we will add the power, we will take the LCM, so we will get 3 plus 2 is 5 by 2 divided by 5 by 2 plus x raised to the power 1 by 2 divided by 1 by 2, which can be shifted in the numerator. So that will become 4 by 5 x raised to the power 5 by 2 plus this 1 by 2 will shift in the numerator and will get 2 x raised to the power 1 by 2 plus c. So this is the final value of the integral. So that's all in this session. Hope you have understood all the concepts of indefinite integral. Thank you.